There are two types of waves. We'll divide waves into two different types. A transverse wave and a longitudinal wave. Now a transverse wave has a wave, if I've got a wave moving in one particular direction, a transverse wave will displace a particle carrying that wave up and down in the upward and downward direction. Let's see, so a wave on a string is a good example of a transverse wave because the wave moves, the particles move up and down. They're knocked from that central level. Now, if I were to displace a particle on a transverse wave, I raise a string to pluck it, say. Then what happens is that the tension in that string exerts a force on that particle, pulling it back down toward normal. So I've got forces between the particles pulling them back into line. So if I give it a kick, it'll move back. This is why a transverse type of wave requires a solid medium. Now, if I take this column of, these two columns, where these represent positions, and these represent the displacement at that particular position, then for a transverse wave, okay, at x equals 0, the displacement is 0. At x equals 1, I've got a displacement of 2. At x equals 2, I've got a displacement of 3. Then 2, 0, negative 2, negative 3, negative 2, 0, 2, 3, 2, 0, or trace that through. And the wave frozen at that moment in time looks like so. This wave moving to form a plot of a transverse